Hi, and welcome to this short video on u-Substitution, reversing the chain rule. So if we had a function, let's say we had a nice sine function, sine of 2x, and we wanted to take the derivative of that with respect to x. Okay? Well, we know the derivative of sine x, we don't know the derivative of sine of 2x. Right, so we needed to do a u-Substitution, right, where the value, the derivative, right, was equal to some f prime of u times u prime. In this case, f prime of u is going to be the derivative of sine u, and u prime is going to be the derivative of 2x. Right? So this would be cosine of 2x times 2. Right? So the derivative is 2 cosine 2x. Okay, so what if we turn that into the integral, right? So we're looking for the antiderivative. The antiderivative of 2 cosine 2x dx. Well, we'd have to remember where our chain rule came from, right? Where the 2 came from. The 2 came from inside, right? So that's exactly what we're going to do from u-Substitution. Okay, so we're going to do u-Substitution. We're going to be looking for an inside function, okay, which we'll call u. Okay, and we're going to be looking for, along with that u inside function, there must be a u prime. So with that, I'm going to take a second to talk about du and dx and how this is going to help us get to a nice, easy u-Substitution pathway. So just kind of scroll that out of the way for a minute, if it lets me. Okay. Doesn't look like it wants to. All right. Okay, so since the beginning of the semester, I've been emphasizing that du, dx, dy, that dx means something, right? It's not just two letters that are there. It means the smallest change in x or the smallest change in y or the smallest change in t. It's an actual operation, okay? So what we're looking for, right, when we look for this u-Substitution, this internal, okay, we're going to be looking for a u. And we're going to be looking for u prime. Let's write that in the red, right? U prime. Well, what this is really saying is du dx is equal to u prime, right? This derivative of u with respect to x is u prime. Here our u is a function of x, so we have du dx. Okay? Well, we can separate this, right? So now we can separate the du and the dx. So we can write du is equal to u prime times dx. And this is where our substitution is going to come in. Okay? We're going to replace our u's in our integral, so that we're taking our integral of just u, and we're going to be taking our, and with that substitution is going to go in du. So we're going to substitute in u, and we're going to substitute in du. So everything that's with du must go in, and everything that's with u must go, must come out. Okay? All right. So what does this mean for our derivative that we were just looking at? Okay? Well, we have to, oops, let's get rid of that. Okay. All right, so let's come over here and let's do some things. So now we've established that u, okay, is equal to 2x. Okay, so when we do our substitution, where we see 2x, we're going to put u. Okay, and we now are du dx, right? So du dx is equal to the derivative of u dx, okay, also called u prime. Okay, well, what is our du dx? The derivative here, 2x, is just 2. Okay, so when we rewrite what du is equal to 2 dx. Okay, so now in our we can see, okay, we've got a couple of things, right? We know we've got our u that we're going to substitute in for 2x. Now we have du that we're going to substitute in where we see 2x. Well, here's our 2, and here's our dx. Okay, so when I write in my substitution, I'm going to be looking at the integral of cosine u du. We're just like that. My u has come out, right? My 2x and my du has gone. Let me rewrite that integral sign. That got awfully messy when I get excited. Okay, so, and now the integral of cosine u du is something we know. The integral of cosine u is sine u plus c. Okay, well, now we have sine u plus c. What do we need to do? We need to substitute our u back in. Right. Sine u is 2x. Right. So now that we know the integral of 2 cosine 2x dx equals sine of 2x. Right. We just saw it, right? We took the derivative of sine x, sine 2x, came out, we went back and forth, okay? That works out. Okay. But what happens now if there's not everything that's in there, okay? If there's not everything that we need. Okay, so let's take a step back. Okay, to look at another style of function, right, that has a chain, sort of a chain rule. Okay. Let's look at if we were taking the derivative, okay, of let's keep it sine and cosine, right? Of the derivative of sine (5x) dx. Right. And now we've been doing this long enough. Right. We know that this is just 5 cosine 5x. Right. Okay, that's pretty straightforward. So what if we had now what we were taking, instead of the 5 there, we were asked what is the integral of cosine 5x dx. Right, so we're going to do the same process. Right now we know we're going to look for an inside function. Okay, well here we've got an inside function. So u is 5x. Okay. Now we need that derivative, right? We need u prime. Well, we're going to establish u prime. U prime is 5. Well, now here's a problem, right? I don't have a 5 to make my substitution. Okay, well, let's remember what we were doing here, right? We said that du, okay, is equal to u prime dx. Okay, well, that means du here is equal to 5 dx. Okay, I don't have the 5 there, okay, but I have a dx that I can substitute, right? I know I'm going to be able to take this 5x, turn it into a u, okay, but now I still have dx, right? And with dx, I'm allowed to bring in or remove constants, right? So here we have dx, and here we have dx. So this just gets rearranged just a little bit. Right? So what we can say is that du, right, if I divide both sides by 5, right, so that du over 5, or 1/5 du, is equal to dx. Okay. So now I'm going to be able to substitute 1/5 du into my substitution. Okay. So now I'm going to be looking at the integral of cosine u times 1/5 du. Right. Now I use my properties of integrals. My constant comes outside. Right. The 1/5 cosine u du is equal to 1/5 sine u plus c, 1/5 sine 5x plus c. Okay, so now I know the integral of sine 5x dx. Whoops. Cosine 5x dx is 1/5 sine 5x plus c. Now, if we wanted to test that, all we have to do is take the derivative, right? So we can just ask ourselves, what's the derivative? Well, the derivative of sine is going to be cosine. Cosine 5x, my inside function is 5. I'm going to have 5 over 5 cosine 5x. All right. And so we're going to be left with cosine 5x. And lovely, cosine 5x, cosine 5x are the same. So that's the process we're going to do for every single one of these that we see. Okay, we'll do a bunch more in class, but that's what we're looking for. We're looking for an inside function, okay, where the outside, that inside function has the derivative u prime as part of it. Okay, now it's important. Things we can bring in with du, constants. Okay, we can't bring in an x or an x squared or any of that stuff, okay, for now. Okay? Right now, we're going to be concerned with only bringing in constants to help us find the solutions to these things. All right, I hope that was clear to you, and if not, please reach out.